So in this video, let us see the derivation of the conductivity of semiconductors. So it is mostly asked in the examination for the long answer question. So I will explain you simply. So let us consider that it is a semiconductor with the cross section area of area R and having a length L. So this is x-axis, y-axis and the z-axis. Electric field is moving in this direction. Now we know that flow of current. So I have explained you in the current density. The current density is both due to electrons and the holes. So the conductivity also due to both electrons and the holes. In the above figure, let current I is flowing in x direction. So the current direction is in this direction, x-axis. So it is in the direction of the electric field. And this current is addition of two currents. One is the current due to flow of holes and the current due to flow of electrons. First we calculate the conductivity due to flow of electrons only. First we will calculate the current due to conductivity due to electrons and then we will calculate with the holes. So E is the electric field vector across the small section of semiconductor. N is the number of electrons. A is the cross section area. So L is the length of the section of cylindrical semiconductor. So the semiconductor which we have considered above. So this is the description first we have to write. So now let us imagine that one electron contains the charge Q, but we have many electrons in the semiconductor. So the total charge will be, if there are n number of electrons, the total charge is n into Q. So electron flow due to the electron will be, so the I is defined as the total charge flow by time taken. So the total charge is NQ and the time taken is T. We already know that time is equal to length by velocity. So length is average distance covered by the electron by velocity is Vd. So from this we can substitute the T value here in equation number 1. So after substituting that, the current due to electron is NQ by the T value is L by Vd. We already know that the current density formula is J is equal to I by A, the current per unit cross section area. So that is J is equal to, we already have the I value here. So I am substituting NQVD by L and area is A. So from this we are considering that N is equal to N by LA. So substituting N is equal to N by LA, we can get that NQVD. So number of electrons per unit volume, and also Vd, drift velocity is equal to mu E, electric field, from 5 and 6. So from these two equations we can say that substituting Vd in place of mu E, we are substituting in place of Vd. So that is J and Q, in place of Vd we are substituting mu E. So this is the current density and J is equal to, this whole part is equal to conductivity because J is equal to sigma E. So from this sigma is equal to conductivity is equal to NQ mu E. So this is the current density due to electrons. What will be the current density due to holes? So in place of number of electrons we are placing number of holes. The charge is Q, mobility of electron, mobility of holes. So this is the conductivity due to holes. We have conductivity due to holes and conductivity due to electrons. Conductivity due to electrons is NQ mu E. So what will be the total conductivity sum of these two? So by adding these two, taking common Q, charge common, so this is the total conductivity.